So today we're going to do this chapter immunity. So there are basically two types of defense mechanism that are present to protect our body from any unknown substance or organism. So the first one is the physical one. I mean, immunity as a whole means is actually about how our body uh, defends our system from attack. I mean, from microorganisms. So first of all are the physical barriers. For instance, the skin's cornified layer. So the cornified layer is actually the dead layer in your skin. So, if a bacteria or any pathogen comes in, it's gonna just lie on the surface. And the other thing is that, but lying on the surface can also cause problems. For instance, infections and stuff on the skin, rashes. So they might also produce oils, our skin itself, which is an antiseptic. It has antiseptic properties, which means it can kill the bacteria. And moving on, our tear glands also produce tears, but the good thing is that our eyes could get covered with bacteria, and the eye is actually cleaned with the tears. It actually kills the bacteria that are present in our eyeballs. The second thing is clotting. So the clotting has two functions. First of all, like a pipe, if the water is flowing and it gets leaked, so the water comes out. So what clotting does, it stops the water from flowing out. But the other thing is, it's actually acting as a barrier for the pathogen to enter. So that's another physical mechanism. Moving on to stomach, like if you have a content, like for instance, if you have something which has bacteria particles in it, so when you eat it, it goes into your stomach, and there is an acid which is hydrochloric acid, and that has a very high pH of around 1 to 2, which is very high, and it can kill bacteria. So it does that. And the last one is you can write, that is mucus, uh, which actually traps bacteria, like in our nasal cavity or in the trachea. There are mucus. When we breathe in, the bacteria might actually get trapped into it. So these are the physical barriers. Now moving on to a more inner response kind of thing, like which acts from the I mean, not just inside, like which is more of like not actually the physical barriers, or it's actually like using the cells to kill the bacteria itself. So that's the immune response. So by definition, the immune response is a complex series of responses of the body that to the entry of foreign antigens. What this means is that any cell, like our liver cell, it has its own special shape outside, which we call as antigen. But it is the response which is against the known antigens. For instance, an yeast might enter, which does not have the same antigen as our body cells. Like it might be different. So it recognizes it, and the last point is it involves the activity of a white blood cell. It actually both of the lymphocytes and phagocytes. So these are the 3 main points you have to know as the definition of immune response for Cambridge syllabus. And so there are two main types of WBC. First one is the phagocyte. So you have to know this definition too, like if you're asked to, right? So it's a type of cell, or if it's a type of white blood cell, you can say, that ingests, it's like eating it, taking it in, and then later after it is inside, it destroys it, usually by using lysosome enzymes and stuff. So by doing these two things, and the thing that it destroys can be either the foreign particles, which is the pathogen, or it could be the our own cell which has been infected or has been damaged. So we don't need a damaged cell, like it has to be removed and new cells have to be formed. So this is the way you do this. So the process you do this by is by phagocytosis. So note that if you are asked, so what is phagocytosis? We learned earlier that it's basically endocytosis, which means bulk transport or taking, transporting like large molecules. Uh, Phagocytosis is a type of endocytosis. So we learned that one type of phagocytosis is one type of endocytosis, which is taking in of large molecules, is phagocytosis, and another one is pinocytosis. So, so that's it. Endocytosis is the taking in of large molecules, but in phagocytosis, one extra thing is that it's the destroying of the engulfed uh, object or the engulfed pathogen or the infected damaged cell. So moving on. So phagocytes are of two types. So phagocytes, this ingesting cells. So this white blood cell, which is cell eating, engulfing, are of two types. So one is the smaller one. They both engulf, take in, they do endocytosis. They do phagocytosis, which is a type of endocytosis. And the one, neurophiles are smaller, and the macrophages are actually larger. So they're small cells, they are a little smaller, and macrophages are a little larger. But the main difference you will find is that nucleophiles are phagocytes, but if you look at the nucleus, you will see that they are like this, a little bit spread out, and they're connected like this. So this is their nucleus. They are like this. So connected nucleus with different segments. So these are the segments. But the macrophages, as I said, this is a little large, and then the nucleus they have is actually also very large at the same time, and they cover most of the cell content. So it's large, and it's large. It's usually a little heart shaped if you look closely. And the other main difference is that they're actually found everywhere, like in the body, in the blood. They are found everywhere. They are mostly found, and they are the ones who start doing the fighting thing. They are the ones who started. So they are found everywhere in the blood. They lie around, and they're the primary fighting cells. So initially, they are the ones who start the engulfing and the attacking thing with the pathogen. But when they start to fail or they're getting slow, and that's when macrophages come in. What they do is they usually work when neutrophiles fail or can't work fast enough. The thing what I was saying. So, for instance, they are failing, and the pathogens are actually winning. They're attacking more. they're dividing more, and the nucleophiles, the a type of phagocytes, which is failing and it's not efficient anymore. So macrophages come into play that time. They do the same thing. I mean, in this syllabus at least, they are like the same, but one is the structural difference, and another is that uh, they come into play a little later. They, you can say they are secondary fighting cells, and then the other thing is they are not found everywhere. I mean, they are found everywhere, but usually, most often, they are found around organs. For instance, uh, around the liver, you can find macrophages, and around some organs, specific organs. So that's that. So an interesting analogy that I made myself is that, so neutrophiles are like police, you can say. I mean, that's my analogy of understanding. I mean, you will find it easier if you like look at this analogy. Like, they are like police, they are found everywhere in a country, and uh, so if there is a robbery, let's say the robber, the thief is the pathogen, so the police can immediately act, but and they can be found everywhere, just like police. But police, they don't have the ultimate power in the country. There are also other special forces. So if police are failing, I mean the robber is too big, so you might need a special force. So that's the macrophages. So they, you can say they are like special forces, like RABs or CIDs, but they are not found everywhere, and they are like secondary ones, and they are found in specific areas, just like macrophages are found around livers and some specific areas. So after they are failing, I mean CIDs can come into play, like, so macrophages can come into play, though they have the same task, and that's it. So as I was saying, the shape is a little smaller. First, it's a little smaller, and the nucleus, they are segmented, and they're connected as well. And macrophages, they have the same function, phagocytosis, taking enough materials, destroying them. But this is like the secondary one. It has a bulky nucleus, and it's usually heart-shaped, as I saw, I mean, in my book. And they're a little larger. So one is it's larger, and the nucleus. And that's it for neutrophiles and macrophages. So moving on. So as I said, I mean, as we know actually, WBC, white blood cells, are of two types. One is the phagocytes. What we say is that they take in the materials and digest or kills them inside. Not kills, I mean they destroy them inside. So this is that, and the other thing is the lymphocyte, which is actually not directly like attacking. What they do is like they produce chemicals and stuff to, and we will look at this now. So there are of two types. The function is same, just that one is primary and the other one is I mean, it comes into play later. One is found everywhere, and other one is around some special areas, I mean, of or special organs, which is the smaller one is neutrophil and the bigger one is macrophage. So that's it, done. So coming to the lymphocyte. So lymphocytes. So by definition, you can say it's a type of WBC or a white blood cell, which is involved in immune response, of course. And difference is that it's very slow. Unlike phagocytes, they are like really fast. They can attack any, like, for instance, I mean, I will talk about this later, but I can say something very shortly, like, phagocytes, they don't need any special. They just see if the antigen matches with the cells. If they find it foreign, they just attack this. As simple as that. But in lymphocytes, what happens is that you have to make special antibodies, which is specific for specific uh, uh, pathogen. So that's very lengthy process, but not if you have a memory cell, which we'll talk about later. So there are two main types of lymphocyte, which is the B lymphocytes and the T lymphocytes. So let's first talk about B lymphocytes. So what B lymphocytes do are they're lymphocytes and they create antibodies. So what they do is that it's a cell with a nucleus, and they mm, produces antibodies. That's what they do. So within that there are two types. One is the memory cell and the other one is plasma cell. So memory cells are like they are not too much. So the plasma cells are the ones who actually are into like the working, like actually producing it and killing it, and memory cells are like the database. They are like the law book. For ins- uh, uh, for instance, like let's get into the police example. So there are a lot of people in the world. I mean, and uh, you can only punish the thieves. So the face of the thieves, I mean, there should be uh, like evidence. There should be people who are evidence. So they're like evidence, and plasma cells are the police who actually captured them. So and the memory cells, the evidence doesn't have specific function. Like they are the only the identifiers. Like uh, they are like yeah. So they are like identifiers, and they can be also like the law books. Like for I mean, for if you are a thief, you have to produce. I mean, you have to give him a fine, and if he's a murderer, you have to give him a jail. So like that, memory cells, they remember the face of the thief. Like that analogy can be used. They remember the antigen of the bacteria. For example, chicken pox. Uh, so once you are caught with that, they remember it, and the next time, if you are caught again, they can easily identify it and produce a lot of plasma cells from the memory cells. So, so they act as a memory of pathogens, and the plasma cell actually they are the functional one. They actually produce that specific antigen. Sorry, the antibody that that is this is the antibody, and this is the antigen. Let's say of the pathogen. So this is complementary. I mean, this antibody and is complementary to this antigen, so it can bind, and the skill or it binds, and later what happens is pathogen recognizes it and can digest or it can kill instantly. And the other function is it can also neutralize toxins. Like they produce a lot of chemicals which can be harming as well. So the antibodies can actually also neutralize the effect of the toxins. But the problem is that for instance, you are uh, now you cured, like you I mean, you overcome chicken pox, and they are not, I mean, present anymore. Like the plasma cells, the police, I mean, they are not, I mean, present anymore. After you are, I mean, you have overcome the disease, you are like okay, and they eventually die. But what remains is are the suspects. I mean, not the I mean the evidence, the memory cells. So they are the ones who live forever. I mean, usually they are long lived. I mean, and they live for the rest of the life. And what we see is that they do not contribute to the attacking of the pathogen directly. They are like the database. I mean, the identifier type, and they, whenever like if you have chickenpox again, they can instantly, they remember it. They can identify and instantly produce plasma cells, which can eventually produce the antibody and instantly, like, very soon kill the pathogen. Destroy the pathogen. So, I've given an example. Like, if you recovered from chickenpox, for example, so so it was destroyed by pathogen. Like, if you are recovered, what happened was, like, the plasma cells produced antibody, uh, which which got bound, which binded to the pathogen, and they did the task. So the antibody will be, produced, and later what we see is, as I told earlier, that the plasma cell will die, but the memory cells will stay forever. It will, usually stay for a long time, and again, if they find the chickenpox pathogen again, so the memory cells will instantly turn into plasma cells, and they can start working again. So for today, we will leave it up to this, and we will continue in the next video. Hope to see you next class.